All right, let's get right into it. Have you ever started a project and everything's going great, but then a few features later, your code just turns into this complex monster? Yeah, if that sounds familiar, you are in exactly the right place. We're going to talk about that huge mindset shift from just, banging out code to actually designing professional systems using object-oriented programming. Seriously, does this hit close to home? You build one thing, then you add another, and before you know it, you're trapped in this tangled web of special rules and exceptions. And hey, it works, right? But you live in fear of the day someone asks you to change it. Trust me, this is a super common growing pain for devs, and today, we're going to untangle that mess. So check this out. It's like a tale of two different worlds, right? Over on the left, you've got what we've all done at some point, this giant blob of code, just endless if-else-if checks, everything hard-coded. Then you look to the right, and it's professional. It's clean. The logic is separated. It's flexible. Our whole mission today is to show you how to get from that messy left side to the clean, pro-level right side. Okay, so how do we make that leap? Well, the secret, the antidote to all that messy code, it's not some new library or a fancy syntax trick. Nope, it's about completely changing how you think about a problem before you even write a single line of code. It's all about starting to think like an engineer.
And you know what? This engineering mindset really just boils down to 3 simple steps. First up, you got to identify the main things, the objects in your system. So for a bank, the obvious one is an account. Step 2, you find what behavior changes between different types of those things. A savings account and a checking account both let you withdraw money, but they do it differently, right? And finally, step 3, you protect what's absolutely critical. You set the ground rules that can't be broken.
All right, enough theory. Let's make this real. We're going to take that 3-step process and actually apply it to build the blueprint for a super flexible, pro-level bank account system.
And here it is. This is our blueprint, the base account class. It's super simple. It just says every account will have, an account number and a balance. But look closer at that withdraw method. It literally just raises an error. Now, why would we do that? It's actually a brilliant rule. It's a contract that says, hey, if you want to be an account in my system, you must provide your own way to handle withdrawals. It's non-negotiable.
This idea, this blueprint or contract, has a name. It's a core concept in OOP called abstraction. And all it really means is that we're hiding the messy details. We're basically saying, look, I don't care how you withdraw the money, just tell me that you can. We're focusing on the what, not the how.
Okay, so now that we have our blueprint, we can start creating specialized versions. Here's our savings account. See how it inherits from the main account? It gets all that basic stuff for free, but it provides its own, very specific version of the withdraw method. And for a savings account, the rule is simple. You can't withdraw more money than you have. Makes sense.
And this is where the design really starts to shine. Check this out. A current account, or a checking account, it uses the exact same interface. It has a withdraw method, just like the blueprint demands, but its internal rules, totally different. This one allows for an overdraft, so the balance can actually go negative. So you've got 2 completely different business rules, but they both follow the same common contract.
Okay, so we have our different account types. Each one knows its own rules. Now for the really cool part, the part that ties it all together. How do we manage all of these different accounts without making a complete mess? This is where the magic happens.
So here's the million-dollar question, right? How are we going to process a withdrawal for any account without writing a giant, ugly if statement? If it's a savings account, do this, else if it's a current account, do that. Because if we do that, we're right back where we started, in that tangled mess.
And here is the answer. It's so elegant, so simple, the bank service. Just look at that process withdraw method. It's one line of logic. It takes any object that fits our account blueprint, and it just calls withdraw on it. The service has zero clue if it's a savings account or a current account. And the best part, it doesn't care. It just trusts the account to handle its own business.
So what is this magic that lets us do this? It's another core OOP principle called polymorphism. It's a fancy Greek word that just means many forms. And all it is the ability for a single method call, like our account.withdraw, to do completely different things depending on what kind of object you're calling it on. It's that simple.
And here it is in action. Look, we make a savings account and a current account. Then we feed both of them into the exact same process withdrawal method.
When we call it on the savings account, it triggers the balance check rule. When we call it on the current account, it triggers the overdraft rule. One service, one method, two totally different behaviors. That right there is the power of polymorphism.
So let's just pause and think about how incredibly powerful this design is. First, our bank service doesn't care about the specific account types at all. That means tomorrow we could add a student account or a VIP account, and we wouldn't have to change a single line of code in the service. All the business logic is safely tucked away inside each account, and the whole thing becomes a dream to test.
Okay, let's zoom out for a second. Why are we spending so much time on this little bank example? Because this right here, this mindset, this is the stuff that separates junior developers from senior architects. This is fundamental to building a real long-term career in this field.
And I want to be super clear. This isn't just some cute academic exercise. This exact pattern, this idea of a service that doesn't care about the details of what it's working with, this is the absolute backbone of systems you use every single day. Think about payment gateways, banking apps, massive fintech systems, you name it. This is how you build software that lasts.
So, to wrap this all up, what's the big takeaway? It's that object-oriented programming, it isn't really about writing the word class in your code. It's not just about inheritance. It's a way of thinking. It's about looking at a complex problem and breaking it down, giving each piece a clear responsibility. It's how we tame complexity.
And I really want to leave you with this one thought. The next time you start a project, try not to think, what classes do I need to write? Instead, ask yourself a different question. What are the responsibilities in this system, and how can I design clean objects to handle them? Because that's the heart of professional software design.